Hello, everyone. Hey, thanks for joining us in today's Let's Talk About Data Twitch broadcast. For people who are joining us for the first time, in this show, we talk about databases, we talk about analytics, and all things related to data. So, today again, we have another interesting episode lined up where we'll be building an application with Aurora DSQL. And before that, let me start by introducing myself. My name is Prasad Matkar. I'm a database specialist solutions architect. Uh, I'm based in London and I work primarily on the commercial engines, which is Oracle and Aurora DSQL. And I'm joined today with Ibrahim and Stephen. So, Stephen, do you want to go ahead and introduce yourself?
Sure. Yeah. Hi, folks. My name's Steve Wood. I'm a specialist database solutions architect. I'm based in West Yorkshire, and I'm very excited to be here today. So thank you.
Thank you, Stephen. And Ibrahim.
Yeah, hi everyone, Ibrahim here. I'm one of your regular hosts. I'm also glad to be part of this show today. I'm a database specialist solutions architect. I'm also Prasad's colleague. We work for the same team, and I'm based out of London.
Yep. Thanks, Ibrahim. So, yeah, let's get started with uh,
I think,
a
yeah,
few
we have
things.
a couple of viewers already.
Yeah. Okay. So let's look at the chat, and we have Evie edits saying hello everyone, excited. Then we have excited to watch same year, and we have KV Shetty. Yeah, thanks for joining. Yeah. So yeah, let's get started. Uh,
Pretty
so
excited.
what's Aurora DSQL all about? Yeah.
Oh, are you asking me?
Yep.
I was going to ask you, by the way.
Ask the audience. Ask the
Yeah.
audience.
Yeah, actually, that was going to be my first question to you. Distribute Aurora Distribute SQL, because yeah, we have
Yeah.
been
So
talking about that for a while now, and I know that it's one of the new products that we have announced recently. I believe it went GA or generally available just recently. Am I right?
yeah, that's correct, Ibrahim. So the product is now GA, which is generally available, and you know like Ibrahim mentioned, so Aurora DSQL is it's a serverless distributed relational database service which is optimized for your transaction processing workloads. The benefits of using DSQL is it can scale virtually unlimited, and it doesn't require you to manage the infrastructure. And at the same time, it is highly available. So it is active depending on the deployment options that you have. You can either opt for a single region or for applications that span across geographies, you can select a multi-region option as well, which increases your availability. Uh, Again, we'll go into these aspects in much more details as well. So, Stephen, you've been working on DSQL as well. Do you have anything else to add? Like, what are the
Yeah.
things that customers love about DSQL?
I think something that may surprise people who see it for the first time is literally all you get when you configure DSQL in a region is your endpoint. So there's
Mhm.
nothing really more to manage it. So there's not a lot of levers to configure. It will scale as your application scales, and each connection gets its own micro VM. And so it takes away a lot of the burden and the pre-planning and the capacity planning that you may have had to have done in the future. And the big win, I suppose, is it's strongly consistent across different regions. And so that's a major plus of it. And so that's what people tend to be the most excited about, in my view.
So yeah, so that's some good news for the developers, but at the same time, bad news for the DBAs, I believe. There's not much of the operational tasks, the usual operational tasks, I believe. If you are saying that once you create it, you just end up having an endpoint to use it, and that's it, right?
Yeah, so it's pretty much you get an endpoint to which you can connect your applications at. And from a DBA perspective, like you mentioned, Ibrahim, saying it's a serverless offering, so
Hmm.
there isn't any infrastructure to manage. So you don't have to plan for your maintenance windows or downtimes. There isn't any. The database will remain up and running even during these activities. There are very less things that the DBAs need to worry about.
But it's quite interesting, Steve, what you just mentioned. Coming from the relational database background and traditional RDBMS engines, when you talked about having a query processor for each transaction, it's quite different from the traditional ones, right?
Yeah. So, I mean, if you think when we first released Aurora, it started to split the different components of the database. So we separated the compute layer from the storage layer. So DSQL just does that. That takes that a few steps further. And when you do that and you minimize the coordination activities between these layers, then that's what lets you scale and scale massively as your application needs. Probably should add at this point where we say that there's no activities for the DBAs sort of amongst us. What you still need to have is a good idea of the right key to use.
Yeah.
So, for example, you can't use things like the serial data type because we want to avoid a hotspot where a key is hot and there's lots of different application sessions having contention on that key space. And so, in in a way, I suppose that's a bit like DynamoDB. So we want to avoid, the
And I believe most of the distributed systems, it should be the same, not
yeah.
having like a hotkey or something like that. Yeah, nice, makes sense. Cool.
And we've mentioned what happens, or that it's a bit more work for the developers amongst us. But should we talk about how the retry mechanisms change and the locking mechanism changes, because that's quite important because it requires a certain amount of consideration. What do you
Yeah,
think, Prasad?
yeah, absolutely. We'll talk into that specific topic about what do the developers need to factor in,
Mm,
or the design considerations. But before that, you know what, let's if that's okay, we could go into the architectural patterns.
yeah.
Primarily there are broadly two different deployment options, depending on the way, or the user base of the application. You could you could deploy DSQL. It's up and running in a matter of minutes. You get an endpoint to which you can point your application at. But the options is you could deploy it in a single region, which is a geographic region which has internally like availability zones, which can be a distinct discrete group of data centers which provide you the high availability and improve your resiliency. So you could deploy it in a single region, where your database is distributed across all the three AZs, providing you that high availability. Or if you have an application which serves the global user base where it is distributed, you can deploy your applications across multiple regions. And then you could have your specific applications pointing to that specific region which is the closest to optimize for latencies as well. uh, when you deploy your applications, or when you use the multi-region cluster deployment, you also have a region called as a witness region. Okay. And the primary purpose of the witness region is to participate in the quorum, and in case of a network split, you can clearly establish a majority on one side of the partition.
Can
So yeah.
can my witness region take any traffic, or what?
So the witness region primarily, it doesn't expose an endpoint. So there isn't an endpoint to which you can point your application at. So the primary purpose of the witness region is to participate in quorum, and to ensure that in case of a network split or an unavailability, you have one side which is on the clear majority side, and which
Mm,
continues to remain operational. So yeah, that's the witness region. Again, the witness region also stores copy of your transaction logs in an encrypted manner, uh, so that in case needed, it can be the applications or the database after one of the region comes up. If it needs to catch up, you can refer the logs there.
Prasad, I'm seeing a couple of our
Yep.
viewers are asking about what the topic that we are discussing now. So extrinsic and what topic life is about. Same thing. body vamp. So a cloud service for what? So maybe we can just recap again.
Loop
We
back on that. Yeah.
yeah.
Yeah, okay. So what we're today discussing about is the new service which was announced at a reInvent of 2024, which is Amazon Aurora DSQL. This service went GA just a couple of weeks ago, and it's a service which is basically it's a database offering which is it's a cloud native database offering which is serverless and gives you the active capabilities. So that so that the end users have less things to manage. They can directly connect to the database, and it provides you uh, 4 nines of availability within a geographic like within the region, and if you have deployed it across, it gives you 5 nines of availability. So those are the distributed databases, the service that we're talking about today.
And we have a demo for that as well.
Yeah.
Yep, we have a demo for that as well. Yep.
And also, Dinesh really
It's like,
asking slightly out of context, old episode in Twitch are missing from season 1. Oh,
Mm,
thanks for highlighting that.
yeah.
We
Well,
will
it's a big
check
amount.
yeah, we
this.
definitely checked into that.
Yeah,
Thank you for highlighting the niche, and we will definitely check that and get back to you.
Do we also need to stress
Uh-huh.
suitable workloads, do you think, for DSQL? So a customer saying, right, okay, well, why can't I put my long running OLAP type queries here? Can I use DSQL for this? So are we going to
Yep.
say, yeah,
So like yeah, that's a great question. That does come up in conversations. But like I mentioned, DSQL right now is more suited for the transaction processing workload or the OLTP workloads. So what that means is, when you run your applications or when you connect to the database and perform your applications or transactions in the database, uh, at the moment there is a transaction timeout, which is all the statements between the begin and the end of transaction. They have a maximum duration of 5 minutes or 300 seconds, whilst a connection to the database has a maximum of 1 hour or 60 minutes of duration. So it is meant for those OLTP workloads which are fast and quick. Yeah, Stephen, that's to answer your question.
yeah. And I believe there's also a row limit per transaction of 3,000 rows. Is that still the case?
Yeah, that's correct. Yep.
Yeah. Okay.
So those are the number of rows.
yeah, but that uh, will lead me to ask you, Steve, a question about
Yeah.
that because you
Sure.
have worked with customers um, on introducing the Aurora DSQL to them. What are from your interactions with them, what are the main use cases that you saw that Aurora DSQL would really solve the issues or the problems that the customers are facing?
Yeah. So think about people who have a need for a highly transactional system that needs very low query latencies, but then
Hmm.
also has to have that happening across multiple regions. And so when you have that situation, traditionally there is quite a lot of thought, planning, and efforts involved in things like DR tests, practicing failovers, moving different endpoints names, and that just with DSQL stops becoming an issue. So that's point number one. And point number two is if we compare it to say global Aurora, whereby you can have a switchover, but it's a planned event and you're going to take a brief outage for that switchover. Well, that just goes away with DSQL because it's active.
Mm.
Um, so there's no concept of, right, okay, now we're going to run in this region, because when you've got a linked cluster, you are by definition having your two endpoints talking to the same data. And it's strongly consistent rights being made to storage, and that's across two different regions. And so that's a big selling point. And so think transactional workloads where the transactions are quite short rather than your longer queries that would maybe go into minutes. So
And
I
also,
think
I've
that's
heard
where
that,
yeah.
yeah, one of the main advantages is that you can also upgrade the database without any downtime.
Yes, definitely.
Yeah, that's correct.
That's
So
amazing.
Mm.
yeah,
How does it
like
happen? So, do you initiate the upgrade? How do you do it from the customer side?
So if you're wanting to do a major version upgrade, then yes, you would initiate that. However, it's important to note that it shouldn't have any impact. So whereas if we compare that to a minor version upgrade, so those will just happen automatically, again with zero impact to your system and your running service. So really the only choice for you is, when do I do my major version upgrade? Minor version upgrades will happen automatically.
Yeah, that's amazing. And I'm not sure if this, my understanding is correct. But, what I know is that it's just a matter of changing the endpoint. If you change the endpoint to the higher version, then that's it. Your cluster has been upgraded. Is that correct?
yeah. So what you mean is, like, on the client connection, you choose the next
Yeah.
version and you connect to the database. So we have a
Yes.
pool of resources, like which is the query processor, which you get connected to. So that's where the query processor is the component that handles the SQL processing, and it passes the engine. So that's where you have the Postgres version installed. So the moment
Mhm.
you switch the connections and you point it to a recent version, it will pick up the query processor of that specific version and you connect to the database.
That's so
Again,
convenient.
yep, sorry.
Yeah, I was saying that that's so convenient. I'm comparing this to the traditional upgrades, the major version upgrades that we go through when you are upgrading any relational database. Yeah, that's,
Yeah.
that's convenient.
I mean, here you can have, like, you can have a version of your application you running on a higher version, whilst you have another version which is
Mm,
running on. So it all depends on how quickly you can move across, but the database is up and available, and you just have to go change the client connections. So yeah,
that's
that
nice.
that's the important thing. So one more important, like Stephen mentioned, about the use cases that he's seen related to uh, like applications, or applications that need to scale, and how DSQL helps them scale unlimited depending on the workload patterns. One more important thing is about the downtime. So there are businesses across the world who cannot afford that downtime, especially, and they don't have or they don't have a concept of a long maintenance window at all. So that's where DSQL will help them with providing them always available, and they can build their applications on the database. So that's thing. And in DSQL, like, it's a disaggregated component architecture. So what that means is each component scales independently, horizontally and dynamically, based on the demands of the workload. So if you have a read-only workload, we would like so we would have more storage replicas to serve the read-only workloads. Whilst if you have more write workload, the write path would automatically scale depending on the demands of your workload. So that's the scalability. It's at the most granular query level, which is assigned.
Yeah. And to add to that, if we go down to the very lowest level, so of the individual Aurora DSQL storage nodes, they
Mm.
are actually aware of the data ranges and the key ranges that they contain. So they can actually perform the filtering for you, and then that can save you a lot of time, and it allows them to scale that bit better. So
Yeah.
that's just an example of how we have split all these different components. And
Oh, nice. So it's not just storage for storing the data. It's there is something running
there's
there.
filtering, yeah,
Okay.
injection, filtering. So it's
Oh, nice. That's
Yeah.
amazing.
yeah.
And then we also touched upon, back to Steven's question about, a new transaction patterns for the developers, which they need to factor in. Since what we have discussed about is the components are disaggregated, which helps you scale well. In Aurora DSQL, we use optimistic concurrency control. Um, so I mean, we've all been we've all been users of relational databases which use pessimistic concurrency control. So what that means is, if I'm working on a resource, I'll acquire an exclusive lock on the resource and continue my activity. So all the other sessions in the database would need to wait until my work is completed, or if the lock is released. I'm sure, like a lot, like as a DBA, we would have faced multiple situations where you have a long running query, a slow running query, which has acquired a lock on a resource, and then all the other sessions in the database need to wait indefinitely for the lock to be released unless someone intervenes or the slow running session completes. When you compare it to the optimistic concurrency control, it's a different way of thinking. In an optimistic concurrency control, the session would execute in the database uh, uh, with little consideration of other sessions that are running in the database at the same time, but it will check for conflicts or collisions at the end, which is at the commit stage. So by avoiding constant coordination between components at each and every stage and only checking at the commit time, we can scale, and it helps you to build the scalable applications or with using Aurora DSQL. So that those are the important things. So from um, from an application perspective or from a developer experience perspective, if you have applications or patterns where you have multiple sessions or thousands of sessions trying to contend for the same record at the same time, because you have that kind of an application, then what you might want to think about here is, um, if two sessions contend for the same row at the same time, then there is a chance or possibility then one of them would get an error. So you need to think about a retry logic. Okay,
Yeah.
that if it fails, there needs to be a retry for that session. And you could also try, whilst you retry, you could also have an exponential back off and a jitter, so that the next time you retry, there's a better chance of the session going through.
I
uh,
wonder if
but
our
Yep, sorry.
I wonder if our listeners know what jitter means in that context.
I mean, look, exponential back off and jitter is primary. Jitter is randomness that you introduce in your retry, so
Yeah.
that if you so you can think about like thousands of sessions trying to update the same record at the same time. One of them succeeds, all the rest would get an error. Now, if they were all to retry at the same time again, then
Yeah.
it would be more amount of work that is needed just for a session, for a single transaction to go through. So by introducing randomness, by introducing exponential backoff and jitter, you ensure that all of them are retried again at specific intervals and have better chances of going through in their retry cycle.
Cool.
So that's one thing that you need to factor in. Another thing is, you can keep the scope of the transactions where you have, if you have transaction patterns where you have a lot of updates or upserts, you can keep the scope of the transactions to as small as possible to avoid collisions during the commit phase as well. So those are the couple of things. And Steven, do you have anything more, or in your discussions with customers, like
Yes. Yeah. So just to compare it to how that particular problem is dealt with other distributed database systems. So sometimes it's the last write wins. Important distinction here is that with Aurora DSQL, it's the first to commit wins. So if two sessions, if session A and session B want to make modifications to the same rows, have a session B that which started after session A happens to do its commit first, session B is going to win, and session A gets a serialization error message and gets asked to retry. And that's where within your application you need the application logic to do that retry, do a exponential back off with the jitter, and so that it eventually succeeds. And your application rights have to be idempotent in that way, so that you're not going to create duplicate entries within your database. Yeah,
I see a question here. I don't think that we might have an answer for this, but
no.
yeah, what's the roadmap to launch it in Sao Paulo? I think we can register the interest, right?
Yeah.
For our
Mhm.
customers in such region. Don't think we have a definitive answer for that right now,
Yeah.
but yeah, definitely we can register the interest.
So it's in how many regions now? Is it 9 or 10 regions? And in the US ones, it's available for a multi-region cluster. In some of the European ones in Japan, it's a single region cluster only right now, but that will change as we roll this out.
Yeah, that's correct. It's constantly evolving, and in terms of the region availability as well.
I think
So
it's
yeah,
time
that
for the
that
demo.
Right. Okay. So should we begin our demo?
yep.
Okay. So I'll be doing the first bit of the demo, and then Prasad and Ibrahim will
Okay.
carry on when it comes to our rewards app. Do we want to give a quick overview of what we're trying to
Yeah,
show here?
I believe so. Yeah, we should do
Yeah.
that. So I think there is a first page, preface page, I believe, that it explains the architecture. Let me try to
Should I?
find that. Do you have that, Prasad? Oh, yeah,
Yep. There we go.
Should,
yeah.
this one.
So my understanding, Prasad, correct me if I'm wrong, we are creating an application, 2 regions, active at the same time. That application connects to an Aurora DSQL cluster.
In the
This,
same region. Yeah.
and
I
yeah,
mean, your
each one,
application deployed. Yeah, it connects to the database in the same region. Yep.
yeah,
And it's
and
active, and it's a reward points application, which you can. Uh, then we can see the product catalog, and then we can add a few items, and then we can see how the active works in Aurora DSQL. At the same time, uh, we can also see how do the OCC conflicts as well look like.
yeah,
Okay. So in the interest of time, should I crack on?
Yep, sure. Let's go for it.
Right. Okay. So bear with me, folks. So first of all, what we're going to do is create a multi-region DSQL cluster, and we're going to do this using the AWS console, and we're going to create the first one in US East 1, so North Virginia, and so I'm in North Virginia, and I'm going to go to the Aurora DSQL service.
okay. That's why I couldn't find the clusters. You didn't create them yet. Okay.
Yes, I haven't created the clusters yet. Yeah, I mean, it sounds like Ibrahim was trying to connect his app to it. Were you?
Exactly.
Yeah,
I thought
yeah.
I'm in the wrong account or something.
Oh,
Okay.
sorry. Yeah, yeah, yeah. So, as you see here, we've got a restore from backup because there's an integration with AWS Backup with DSQL, a single region or a multi-region. So we're going to, in this case, create a multi-region cluster. And we're going to choose a witness region. Remember, our witness region has no endpoint. It has a copy of the replicated transaction log and acts as a
Uh,
voting.
Yeah, Steve, I
Sorry,
just want to stop here because if I
go on.
compare this to the other pages that we have for the creation of the traditional databases, the relational databases, it will have like at least 10, 15 parameters
Yeah,
that you need to specify. But for this one, it just like that. Whether you need
yeah,
it in a multi-region, what's the multi-region setting, and that's it.
yes. So
Wow,
note, even when you compare it to, say, Aurora serverless, I am not specifying a min and max.
ACUs.
Yeah, ACUs. I'm doing none of that. So it's purely
Yeah,
just, yeah. So that's quite. And so all I'm going to do is I'm giving it a tag, so a name. I'm going to call it rewards. So this is just creating the initial cluster in the North Virginia region.
okay.
and it starts to provision that. However, because we've chosen a multi-region cluster then, so we need to continue and complete our multi-region cluster setup. So I shall do that. And we're going to
create a cluster in another region.
And the only region available to us is Ohio. And so I'm going to select Ohio and go create cluster there. And you see it switched us to the Ohio region in the cluster. I'm going to deselect enable deletion protection. I'm going to again give it a tag, and so note the very little additional settings. I could do something with the KMS key here, but that's it. Not lots of levers to pull here at all. If I can spell, that would be nice. And I'm going to create my cluster. And so next, so what's our next action? So because these two regions will need to talk to each other, we need to set up peering, so VPC peering. So what are we going to peer it to? Well, we're going to peer it to the region of US East 1, so that's North Virginia. So we'll select that. And I need to confirm that. And that will, and then that will take a moment or two thinking about it, and then you will see it will move from a pending status to an active status, and that generally takes a minute or two, and then you have your cluster provisioned. At that point,
wow, so 3-4 steps you have created active cluster in 2 different regions.
Yes,
that's amazing.
Yep.
And just because we're doing this in the console doesn't mean it doesn't have to be done in the console. You can do it using AWS CLI commands. You could do it infrastructure as code. So it doesn't necessarily have to be all via the console or anything like that.
So we also discussed about, when we create a multi-region cluster, Steve, we got 2 endpoints for each of the regions.
Yeah, so that's important. So we can show that here. So you'll note, so we're in the Northern Virginia region, and we have endpoint here. So
that's for the first one. Yeah. Okay.
This is for the first one, and then which region we're here. So we're in a different region now, and this is a different endpoint. So 2 different endpoints writing to the same area of storage, or the same storage that gets replicated, and so that's quite, and it will write in a strongly consistent way to those. Now, so generally what you want to have is your applications in US East 1 talking to the US East 1 endpoint, and vice versa. What you might have is applications, in case of an issue with a whole region, you could have some kind of latency-based Route 53 routing, so it would route to the other endpoint. However, just for reasons of latency, generally you would want your applications in this particular region, Ohio, writing to the Ohio endpoint.
Yep.
We'll just give it a few minutes. So whilst we're doing that, maybe we could switch on to the, so we're going to be, oh, wait, yep. Okay, so that was the second region, and this is the first. So functionally, there's no real master to these 2 endpoints. So you could write to either, and that's fine. I think we've completely done the cluster. Right,
yeah,
okay.
It's great.
So yeah, so let me now move on to connecting to it. So we're going to use Cloud Shell for our So back in Cloud Shell, I'll clear the script. So I've got a Cloud Shell session in, easy for me to say, in US East 1, and I've got one, if I just wake it up, in US East 2. And so what we're going to do now is we're going to connect to each of our cluster endpoints as admin. So what I need to do is I need to prepare and export the cluster endpoint in environment variable for each session. So these will differ depending on which session I'm connected to. So we're in Ohio, so I'm going to click on the cluster and I'm going to copy that endpoint. So, and I'll bring up my shout at me, anyone, if you see me making horrible mistakes here, just so it doesn't go wrong. And now this is in North Virginia, so I'm going to do a similar thing. Copy my public endpoint to my notepad, and we're going to do it there. So this highlights, as you see, these aren't the same. These endpoints are different, and so we shall set these in the relevant session and not get them the wrong way around. Otherwise, we'll probably get some kind of permissions error, which we don't want. So this one's US East 1. So we're going to run this one here. And this one is US East 2. So we're going to run this one here. And so now we've done that, we are going to run that script that will essentially set these to my local environment.
So this is, in order to connect to the cluster, you need the endpoint.
Yes.
And then for the authentication.
Yes. So it's
sorry.
Yeah. Yes, that's a good point. So for authentication, we will use IAM authentication. So rather than just a password, what you need to do is generate a token. And so we have our command here that will, it's an AWS CLI command, and we're putting the output into of that into PG password. So PG password is one of the environment variables with it that you use in a Linux environment to set so that when you run a pSQL command, you don't get prompted for various connection details. So I'm going to generate that here. And I'm going to also, what does this keep timing at?
Yeah, I think the default timeout is 15 minutes, right? You change the timeout to more time, is it?
Timeout for the Cloud Shell, you mean?
Yeah.
Yeah, it just seems to be timing out after.
No, the IAM authentication, the credentials that are.
Okay, right. Sorry. Yes. Yeah.
15 minutes.
Yeah. So this value is in seconds.
Okay.
Would it be possible for you to just zoom in a bit, Stephen?
Absolutely. Yeah.
Okay.
Is that better?
Yeah.
Okay. So you're generating the token, and that token will be used to authenticate the user to connect.
Yeah. So if I were to, I mean, you wouldn't echo this publicly normally, but
yeah. So that will be the string that is.
Yes, it's a very long string that I've got from running this CLI command. Okay. We can have a quick look at this file if you want, just to see what else is set there. And so you see one of those is cluster endpoints. So we're specifying that we have to connect over SSL. It's good from a security perspective. And we've exported PG password, and so now we're going to try a P-SQL connection and see how that goes. Very good. So I'm connected to my database.
Mm-hmm.
And this was in US East 2. So if I go back to here, I just want to check that I've got PG password set. Yes, I have. So I'm going to run a similar command here. And yes, so I'm don't have any tables currently. So when I'm doing slashes, these are just your standard P-SQL slashes that do your various commands. So that's just standard Postgres client stuff. So there's nothing exotic about that really. So we have established P-SQL connections to our cluster. So now we can create a schema and load some data. So in order to do that, we are going to use the /i or /include to actually create our objects. So I shall do this here, and that will create some objects for you. So obviously it will drop these objects before, and then if they don't exist, then you will see that kind of message. So note we did that in US East 1. Okay, so that is an example of okay. Let me just reconnect. Bear with me. Right, I'm just wondering what I've done. I would at this point be kind of expecting to see those tables that has created there. Let's see whether it's still running the jobs to do the index build stuff that was taking a while. So let's connect again.
So you're connecting to the first region to check it. Okay.
Yeah. Okay. So various index build jobs have gone on, but they've now completed. And so this is in US East 2. So if I quit out of there, and I'm going to, so I was connected as the same user, connected as admin. And I'm just checking if there's any differences. And I'm just, so I'm looking at the database, and I'm going to
So I mean, you've created the script to actually create the structure right now. What's the next step? Are you going to populate it?
Yeah, so that now I've done that, what I'm going to do is there is some copy commands that are run using a load rewards data script. And so just like the last one created the objects, this one will now load some data. And so bear with me whilst I run this. So what we're going to do is just do a little bit of a few checks and see, do we now have tables with some data? Yes, we do. Okay, so let's just quickly log on here. And yes, we do. So note that that was this select on US East 2 has red data that was imported from a script run in US East 1.
Okay. Yeah.
So
So the
we could
data
get
is replicated and it is strongly consistent from either side that you read the data from. Yeah.
That's right. Yeah.
Okay. That's nice.
Let me just do one more. Right. What was that?
Mhm.
Okay. Yeah. So that slight confusion before, I think, was to do with my search path.
Yeah, I was going to say the scheme is different there.
Yeah, the schema is different. I was expecting it to put it in the default public schema, which is in my search path. But if I do this, yeah, so it will be if these objects had been in admin or in public, then I would have seen them just with a standard /d. However, as it's put them in a different X-point schema, then that was my moment of silliness there. And so I think, are we now are we good to go, Prasad, from your side of things? I'm
Yep.
just wondering.
Just before that, Steve, if you could just bring up the architecture and then just for a moment.
Yes,
Yeah.
of course.
So,
Bear with me.
okay.
So I'll load that here, and
Yeah, it's in the section 3. Yeah. Okay. So what we've done now is, populated the database with the schema and with the tables that are required for the application. In the next stage, what we are going to do is we are going to deploy the rewards point application. So there are two parts to it. One is the backend deployment, which is basically a set of lambdas and the API gateway. Once the backend deployment is done, we are going to use the CloudFormation template to do it. So that's one part which we will be deploying. The second one is the AWS Amplify, and which is the front end web interface through which we'll be accessing the application. So there are two things that we are going to deploy, and post which we'll see how it works. Again, how are we doing for time? Yeah.
12 minutes.
Okay. So yeah.
Sorry. Yeah.
So
I
let me
find it a
now
lot.
share my screen.
Yeah.
Okay. Okay. Are you able to see my screen?
Now we are. Yes.
Okay. So yeah, now let's go ahead with deploying the backend first, for which we will need. So we are deploying the backend, which is the API gateways, the lambdas that are needed for the application, but we'll do it through the CloudFormation template. Uh, so we have all this, which is set up as a part of the demo that we are going to do. What you need to substitute here is, yeah, just give me a moment. We just need a URL, which is the S3 URL where uh, the code is set up. And yeah, let me, oops. Yeah, let me just, I need to, so let me give the stack name as, and the bucket name is where all of this is hosted. So I'm in US East 1 at the moment. So this, then the cluster endpoint, this is the endpoint for the first cluster, for the cluster in US East 1. So if you remember, Steve mentioned about each of the cluster having its own set of endpoints, and I'll let the remaining steps be as is. And yeah, so what we've just substituted is the template URL and the endpoint. Yep, and should be it. Yeah, so this will take a couple of minutes. So whilst I'm doing this for the first region, Ibrahim is performing the
Yeah,
same for the second region as well.
yeah, exactly. I'm deploying the same backend front end in the Ohio region so that we can test the active connectivity to the cluster.
Mhm.
Uh,
Excellent.
Meanwhile, I think also Roger has another question about the IAM authentication and whether there are some other plans to have database authentication. I'm not sure if this is something that we might be considering. Any idea?
Yeah, so I mean, I guess that's question has come about because with things like Aurora, Postgres, standard Aurora, you can either choose to have it password or a mixed, or to have IAM authentication. And so, yeah, if you have a problem using that type of authentication, then that currently restricts you from the service. I think we can feed it back, Prasad, and check it's on the roadmap, can't we?
Yep.
Yeah. I suspect it will be on the roadmap, but we shall certainly check. And
Yeah, I think the reason behind that is mentioned because the IAM requires database roles to be created and mapped. This is a big
yeah,
problem to us to use servers because we have to use hashcode for to manage them. So I think, yeah, that's one of the feedbacks that we are looking for from our customers so that we can
absolutely.
check with our service team there. Perfect. Okay, how's it going with your stack?
Yep.
Is it created already?
Yep. So it's completed right now.
Same here.
Okay, great. So yeah, so once the stack is created, which is the backend, now we'll go ahead and deploy the front end, which is through the AWS Amplify. So before that, once the backend is deployed, we would need to head over um, to the Cloud Shell, and then yeah, let me just okay. So I'm just going to download a file now, which I'm going to use in AWS Amplify to create the front end. So let me download the file, and let me name the file as okay. Okay. So once that is complete, now let me head over to the AWS Amplify. I'll click deploy an app, deploy without a Git. Chooses it. Okay. And I will then save and deploy. Just give me one moment. Yeah. Okay.
You have 5 minutes left.
Okay.
Up against it now. Mainly my fault.
No.
So now let's try to log in. I'll select a user. a random test user, and let me head over to this. Okay, let me go to the cloud formation back again. I'm just trying to log into the application using this.
Yeah. Just for anyone who doesn't know, so kind of Amplify is used for building app front ends and back ends and actually connecting them to back end resources. So it's a kind of a shortcut to some of the heavy lifting and the infrastructure work that you need to do when you've created your app and you have the code. I've got it in the chat, the list of users if you want as well.
Yeah, do you have it? Okay, hold on. Let me.
Yeah. Meanwhile, there is also a comment about if the backup is being enabled at database level, would be a game changing because it would enable to have different apps. Yeah.
Okay. Yeah. So currently, you can have multiple schemas within the same database, although they are restricted, I believe, to 10. I think the idea architecturally is to, as it's so quick to provision, is to have multiple clusters, and that's more the pattern that we're going for with it, just because it will actually scale down to 0. There was an interesting blog that I can share on that. So just like serverless, it will actually scale right down to 0. So you can have multiple clusters, and it's not quite the same as running that, say, with provisioned input instances with all the overhead associated.
So just a quick one, since we are just running out of time. So this is how the application looks like once you log in. You'll have the same on the second URL as well. So I've created the first one. Ibrahim, do you want to share? Is your app deployed on the second one?
Yeah, it's just the password. I'm just connecting right now.
Okay. So let me quickly summarize. So what's going to happen is once you select your item and add it into the cart, if you were to use the second URL and you see, it will automatically get replicated onto the second instance as well, because it's an active setup. And once you proceed on to, out to checkout and confirm your order, you head over to the past orders. All of this is going to be replicated across both the regions.
We just have 1 minute left, Prasad.
Okay. Yeah. Yeah. That's what is an active database, wherein you can connect to it, and you can see the replication in real time.
Cool.
So yeah, that's what we wanted to cover as a part of our demo today. Again, thank you both, Ibrahim and Stephen, and
Pleasure.
thank you to the audience for joining. And I hope you enjoyed the demo and the show overall. Again, do tune in next time at the same time next Monday, where we'll be talking about another interesting topic. And again, thank you all for joining, and have a good rest of the day. Thank you all.
Thank you,
Thank you.
folks.